Hello everyone, welcome back to the course. Today we are going to discuss about stack using linked list. Let me share the screen to discuss about today's concept, that is stack using linked list. By the end of this lecture, you can able to create and implement stack operations using linked list. We already know that the procedure for stack is these are the operations which you are going to use. That is push and pop operations. By using these push and pop operations, we can insert and delete the elements only at one end, that is representing the top. And in a similar way, we are going to discuss, we have already know about the linked list, how we are going to have the structure to be created, a node to be created. In that node, what is going to be present, that is data and address is going to be stored. And the procedure for push operation here we are going to use with stack using linked list. Now we are going to see about the procedure. Step 1, we are going to have an empty stack here, and empty stack represents top equal to null. That means the stack is empty. Now we want to push some element 10 onto the top of this stack. For this, first allocate the memory with the name n and read the data element as 10 and address as null, and you consider the address that was given for this is 1000 and still top equal to null here. Now whatever the new node which you have created, that becomes the top node here, right? Now we are going to place that element, that is 10, is going to be placed or pushed down to the top of the stack, and top is going to be pointing to that node address. Next, coming to the second one, push 20 onto the top of the stack. That means first we need to create a node, allocate the data value and the null value. Data value is 20 here, address is null, and the address here we are going to represent is 2000 and the name of the node is n. And place this on the top of the stack like this, and the name of this node is n here. Now, this is not the top of the node, top of the element that was present on the stack. Now, this becomes the top of the element that presents on the stack. Now, we need to make the connection between this node and this node. Now, making the connection between this node and this node, and this is the name of the node n, making the connection that is n arrow next should be assigned with this 1000. Then we can make the connection between the top node and the below node. With this, this becomes the top node. Now, in the similar way, we are going to push one more element onto the top of the stack, that is 30. This is the situation which you are in. Now, top is pointing to 2000. Now, I am going to create one more node that is 30 with the name n, and this 30 node which I have created, that should be placed on the top of the stack like this way. And the name of this node is n here, and I need to make the connection between these two, and I need to move top to the top element on the stack. To make the connection between these two, I need to make the connection between 30 and 20 by taking its address. What is that link we need to make is n arrow next. N arrow next equal to, it is pointing here is top. The same one we need to do. Now based on this, it is going to move top to 3000. Like this way, we can push the elements onto the top of the stack and representing the top element with top only. And while coming to see about the code, this we are writing the push operation itself. First, allocate the memory, then read the data value, and assign null next equal to none. Now we are going to make the connection from the node which is already present and the new node which you are going to create. We are going to make the link between them. Because of that, we are going to assign n arrow next equal to top. Now, whatever the node you have assigned, that should become the top element. Now, because of that, we are going to use top equal to n. In this way, we can have the implementation of push in stack using linked list. In the similar way, we can able to perform the pop operation also here. First, initially you consider we have 3 nodes in the list. Then if I want to pop the top element from the stack, that is 30 has to be removed. For that, directly we can't remove 30. I mean, directly we can't remove top. Instead of that, what we are going to do is we are going to initialize temp equal to top. Now the top value is going to store in temp. Now based on this, I can remove this temp value and I am going to move my temp to the next location. Just observe here, temp is pointing to 3000 and top I am going to represent with the top equal to top arrow next. That means top now it is pointing to 2000. After doing this, now I can remove this node from the top of the stack. And the similar way, if you are going to observe 20, the 20 element I want to remove from the stack, in that particular case, again I need to initialize temp equal to top, then assigning top equal to temp arrow next. That means temp, now top is pointing to 1000. Now I can remove the top element on the stack. Now the same thing is going to be applied for the next one. If I want to pop 10, then I need to assign top equal to top arrow next. Now top arrow next will be pointing to none. Now I can free the temp. Now when I'm going to reach top equal to null means you don't find any elements in the list. Then that leads to an underflow condition. See the implementation part of pop. Here we need to assign temp equal to top, then top equal to top arrow next. That means top is pointing to the next address. Next we are going to free temp. That means it is going to remove the top element from the list. Thank you for listening.